Hello and welcome everyone. Um, my name is Barbara Wishingrad with Sweetwater Collaborative, and I'm here with Fred Hunter and Josh Branning. Fred is the main instructor, and Josh is also an instructor for our curb cut webinar today, and I am happy to have you all here. Um, thank you for but anyway, this is the first time that Sweetwater is doing a webinar. So we're just learning how to do that on Zoom. We have participated in a couple of webinars presented with the city of Santa Barbara, but they handled all the technical details. So let's just jump right in. Curb cuts as part of a bigger picture or a shift of paradigm shift to change the pump pipe and pave it paradigm to slow spread and sink. And we have a PowerPoint to talk more about why that's important and give us a background on it. And I'm gonna have Fred take it away. And do the PowerPoint. Thank you.
Yeah, and as far as little just housekeeping, you might mention about questions. If you have questions to submit in the question and answer tab, to please go ahead and submit those, and we'll try to address those at the end of toward the end of the presentation. So then I will go ahead and share my PowerPoint screen. Hopefully that will work correctly.
And I just want to say one thing also is that we are recording the webinar, so you'll be able to see that afterwards also. Thank you.
Okay. So here we are with our presentation on curb cuts. And can you hear me okay, Barbara?
I can hear you fine, thank you.
Just wanted to verify that audio was still good. I wanted to start with a kind of a little brief overview of the hydrologic cycle. Many of you are, I'm sure, no doubt, very familiar with this, but just it bears bears mentioning for a couple of reasons. You can see from the diagram how condensation of water vapor in the air forms clouds. And then when we have precipitation, that falls on the land. On our mountains, that water runs down in streams and fills lakes and reservoirs and such as that. And much of that water makes its way into the ground into the water table through groundwater. It stays near the surface as soil moisture, or infiltrates down into the groundwater basins. Some of it might even continue on down deep into aquifers, way down deep in the ground. But a lot of it will move through a subsurface flow in the groundwater basins. And of course, trees and plants growing in the ground will remove some of that water and send it back into the atmosphere through transpiration, through the leaves of plants that are growing. One thing that's really interesting in this diagram I wanted to point out is the groundwater outflow, where it interfaces with the ocean, is a critical factor for communities like Santa Barbara on the coast. Clearly beneath the ocean, there's also a water table of salt water that is beneath the ocean. And the constant replenishment of the freshwater groundwater table is critical in order to keep that saltwater groundwater at bay. So there is a give and take between the saltwater groundwater intrusion and the freshwater that's coming from the land. That's an important factor, and one of the reasons why it's so important for us to continually try to increase the amount of infiltration that happens in our urban settings. So let's go ahead and move on. And again, I'm going to apologize for some of the quality of the images. These are just handy images lifted off the internet in an attempt to kind of give the concept that we're discussing. This one is not particularly very doesn't have great detail. It's kind of pixelated, but I thought it was a good image to demonstrate the discrepancy between urban environments and environments that have more natural ground cover. You can see that in the area with natural ground cover, there's a great deal more infiltration happening. We get a lot more shallow infiltration, a lot more deep infiltration. In an urban environment, that is limited by the hardscape surfaces that are present in the urban environment. So we're going to get much less water getting into groundwater, and we're going to have much less natural evapotranspiration happening from plants and planted areas in what would be a more natural landscape versus an urban landscape. This is just another image that reflects the same sort of thing, but you can see that the urban area with more impervious surfaces ends up having more runoff, more surface runoff. An area that is more vegetated is going to have more subsurface flow. And that's one of the key issues that we want to try to address with curb cuts, is in increasing that subsurface water and minimizing the surface runoff. So some of the downsides to urban runoff, and one of the principal things is the pollution that comes along with the water running off of our urban landscapes, our streets. There are hydrocarbons, oils, other car fluids that are going to be on the city streets that are going to run off. There's sediment, bacteria, pet waste, trash, this kind of stuff, fertilizers and pesticides from landscapes. All of these are going to be contained in the runoff and end up in the creeks and the ocean. And that is one of the main concerns, is the water quality. And a lot of the rules and regulations that are being, that we're seeing come around in municipalities and counties and such, are an attempt to address the requirements to minimize this pollution going into waterways. Other downsides to urban runoff is flooding downstream. The more water is running off and the more quickly that's running off, the more flooding we can see in the downstream regions of a watershed, which is a big issue. There are parts of Santa Barbara, for instance, that are prone to flooding in heavy rain because they're the low-lying areas. The other downside, as we mentioned, talking about the groundwater basins, is the essentially our urban infrastructure has become a massive urban dehydration system. And the more that we are losing water in runoff, we're essentially slowly dehydrating our landscapes from that normal hydrologic cycle that is the ideal that we want to try to return more to. So that systematic dehydration is really an issue that we want to try to address. Here is just a little video just showing some of this is runoff on Lower Salinas Street in Santa Barbara. But look at all the beautiful fresh water on its way to the ocean and carrying whatever pollution that is there on the street is headed right out to the ocean and into the creeks. And so clearly we want to try to do the best we can to put that water to good use rather than to just let it run away. So how can we turn some of that runoff into run on? Curb cuts are a very good tool that we have to help try and get things going in the right direction in that way. Our curb cuts increase the infiltration in groundwater. They're a way to also filter and treat that pollutants And things that are in stormwater are much better handled in a terrestrial situation. They can be broken down more easily with bacteria and fungi in the soil than processed in a marine or aquatic environment. So it's really an essential thing to get those pollutants out of the runoff stream and into a situation where they can be mitigated by biologic activity and binding of soil. The soil is a much better medium for filtering water. Then it makes more sense to do that than to release it to the ocean. We're also reducing that downstream flooding, and we're providing deep watering for the urban landscape, for our street trees and things that really desperately need that water. So these are the things that curb cuts can do for us. And I thought it'd be interesting to look at some of the volume considerations, just so we kind of have an understanding of what kind of volume of water we're talking about. Is really quite extraordinary. 1 inch of water over 1 square foot is 0.62 gallons of water. If you see the little 1 square foot cube over there on the side, and imagine that to be 1 inch deep with water. If you could pour that 1 inch of water out of that cube, you'd have 0.62 gallons of water. So 1 inch of rainfall is equivalent to 1 inch of water over every square foot. So typically in a 1 inch rain over 1,000 square foot of watershed area, you're going to get 620 gallons of rainwater that falls on that 1,000 square feet. We can extrapolate upward to the size of an acre. Over an acre, that comes down to 27,000 gallons of water over 1 acre that falls in just a 1 inch rain. I thought if we look at the 21.09 square miles of Santa Barbara, that's the official size of the city of Santa Barbara, in a 1 inch rain, that's 369,532,382.7 gallons of water that falls from the sky over the city of Santa Barbara in a 1 inch rain. It's a huge volume of water. So
that's not considering the other areas of the county and Goleta and Carpinteria and everything that's just the city of Santa Barbara.
Just looking at the city limits and the geographic boundaries of the city of Santa Barbara. So we're talking about an enormous volume of water that falls every time it rains. And so we want to be doing our best to capture that and get that into the ground as best we can. So obviously our streets and roads are an enormous impervious surface that is an opportunity for us to capture water. These are some statistics from Brad Lancaster, our friend and colleague who's been a pioneer in the area of run-on capture for a long, long time. And a 10-foot wide paved street will drain 27,800 gallons of water for each mile of street. And those are actually conservative numbers listed here. These numbers actually represent an 85% of the actual water that falls. There are some inefficiencies in surface areas may absorb some, water may go down cracks and not actually end up running down the street. So Brad's attributing an 85% efficiency to this collection of water off the urban roads. So these numbers are actually perhaps even a little low for what the volume of water that would be generated realistically in a 1 inch rain over a certain length of city street. So we're talking about large volumes of water. So great opportunities there exist, in those numbers. So curb cuts are a very simple way to divert some of that water that's rushing down the gutter into the landscape and provide it a place to pool, to slow, spread, and sink into the ground. So this is just a little simple diagram of a curb cut, and to give you an idea of what a curb cut might look like. But let's look at a whole bunch of examples of curb cuts from around the country, around the world, to give us an idea of what what variety there exists in the way of what's possible with curb cuts. This shows the execution of a curb cut. There's someone with a concrete saw actually cutting the curb. You can see the basin has already been excavated where the water will flow off of the street. And just interesting to see that in process, to see the depth of the basin. You can see what large capacity exists there to accommodate lots and lots of water as it runs down the street. Here's a beautiful curb cut after a rain, full of water and looking like a beautiful placid little lake. All that water will be able to infiltrate into the ground and feed those street trees that are in the near distance there. This would be very beneficial to all those plants and trees.
And this is just wanted to step in there. This is an example of an eddy basin. So the water comes in on the street, fills up, and once it's full, it passively pushes its way back out to the road and just continues on with the rest of the flow. So it's a pretty simple, low-tech deal, low clogging issues, things like that.
Super low tech and super safe because it's passive. When the eddy basin becomes full, it simply water stops coming in and it just becomes tranquil. So it's a very safe and effective passive means of capturing water. Here's another one that I think showcases how beautiful these basins, these infiltration basins can be. They can be landscaped very nicely so that they're beautiful to look at and a real enhancement to the urban landscape. I would say that for my money, the landscaped area in the foreground that's the infiltration basins is far more interesting and beautiful than the far distant zone that's full of turf in the background there. I think this makes for a much more interesting parkway and a much more beautiful urban landscape. So let's continue to look at some examples to just see. And these images were curated by Art Ludwig from around the country. He did a lot of work in collecting images, and I'm borrowing his images here. And when I know from where they come, I'm listing the location. This is in Philadelphia. Some of them I wasn't sure where they were from, so I haven't listed the name, but this is Philadelphia. And you can see how beautifully lush those basins look. And in this instance, they have used metal grating to cover the channels that conveys the water from the gutter into the curb cut basin. And I even noticed in this example, there's some little asphalt berms they've built in the gutter to add a little dam, if you will, that will divert more water into the basin than would if there wasn't that little asphalt berm there to divert it. The more water would just rush past, but they're increasing the capacity, increasing the diversion into the basin by putting a little bump in the street to enhance the infiltration, enhance the capture of water into the curb cut basin. So that's Philadelphia. This is another one from Philadelphia. You might notice too, the little cuts there on the sidewalk side. They've got a zone of permeable brick paving there, but they've also left cutouts on the sidewalk side for water that falls on the impermeable aspect of the sidewalk to flow into the basin, the infiltration basin as well. Here's a couple of other examples. You can see how deep the basins can be. And again, notice the cutouts on the sidewalk side there, allowing water from the sidewalk to flow into the basin as well. And things can be very beautiful and quite enhancing to an urban environment. These are images from Portland, and a couple of basins there. Again, the sidewalk is already, looks like they've used permeable paving on the sidewalk. But the lush growth in the basin is a testament to what a vibrant soil ecology is going on in that basin. And this is something we probably would talk about a little later on too, but it's evident that the more growth, the more lush living plants there are in the soil, the more roots, the more the soil biology is active, the more capacity the soil has to infiltrate moisture. So the planting is a very important aspect and something that makes the system more regenerative in that it gets better and better over time. Its capacity increases with time. And here's an example from Palo Alto where they've had looks like a bulb out traffic control kind of circumstance that they have fitted to be a curb cut infiltration basin. Here is a little scene from Ventura. This is, you can see the water flowing from the gutter into the curb cut basin. And you can see that there's quite a bit of water coming in, being captured from the street there. That's from Ventura. Fairbanks, Alaska. This is just an example of how these kind of strategies work across the board in different climate types and different zones, northerly climates, southerly climates, dry, wet, cold. It almost doesn't matter. A curb cut can and infiltration basins like this have validity and purpose in just about any climate you could think of. So it's interesting to see that they're doing it in Fairbanks, Alaska, as well as Tucson, Arizona, two very different climates. Tucson famously in a climate where there's not a lot of rain, but when it does rain, the rains bring lots of volume. So these are quite large basins that are dry most of the time, most of the year, except when there are large rainstorms to fill them up. So here's another example of a curb cut that is, rather than a curb cut, it's a curb core. And that's what we saw in the last slide. The guy was drilling with a curb coring device to cut a hole through the curb rather than to remove a section of the curb, which is what we typically think of with a curb cut. This would be more of a curb core. You can see the upper left shot there is of the hole in the curb right at the gutter level that's angled downward into the basin, and then the shot just below that is the backside of the curb where the water will flow into the basin that's been excavated. The other two shots show the basin. Actually, I think this basin was under construction when there was a rain. The basin was not, the rock work around the basin had not been completed before the first rain came, and the first rain came and filled the basin right up to the brim with water. So the upper shot shows some of the construction of stonework around the basin, detailing it out after that initial flush of water had already been infiltrated. I think these are shots of the same that same basin. You can see how once the basin is mulched and planted, it has much less of the effect of being a giant bathtub and more just looks like a lovely landscaped area rather than being a deep basin, bathtub-like basin. It looks more just like a lovely landscape. Couple more shots of beautiful, curb cut basins and urban situations, and you can see just the capacity is quite large when it's well designed. These attributes can really take in a lot of stormwater and process and clean and infiltrate large amounts of water. And if they are repeated consecutively throughout an urban area, they could certainly make a huge impact on the amount of runoff being discharged to creeks and to the ocean. So there are some aspects we would want to consider with potential curb cuts. Barbara, did you want to say something?
Yeah, I just want to emphasize the role of curb cuts in preventing or mitigating downstream flooding, which we have seen has been an issue in our community before. And I think that this is part of the solution to that in our community. And I think it's something that we should really rally around for that reason also.
Yep, for sure. So in choosing ideal locations for curb cuts, there's clearly some considerations that need to be looked at. Not every parkway is an ideal setting for a curb cut. And when you start looking at these aggregate considerations, it's actually more challenging than you might think to find really good places for curb cuts. But that doesn't mean that we don't believe that there are ample opportunities throughout our South Coast communities to construct curb cuts. But some of the things that to be considered are the parking access, pedestrian activity, bicycle lanes, the safe movement of autos and pedestrians and bicyclists around. All of that is obviously something that's important. The safety. Excuse me. Although, and I know that there's been there's a great concern with municipal governments about those safety issues and potential lawsuits from people that might trip or be injured. And I think what I would say about that is that if Fairbanks, Alaska, and Philadelphia, and Palo Alto, and Ventura, and all the places we looked at before have found a way to live with that risk or to address those concerns, then I think that we ought to be able to do that here in Santa Barbara, in the Santa Barbara area for sure. It is possible, and I don't think we should let those concerns stop us from doing this, because I think it's just too important to overlook. Obviously, there are different types of infiltration capacities of different types of soils, and soil types vary from location to location. Some places are sandy and have a high infiltration rate. Some places are heavy clay and have a very low infiltration rate. The one thing I would say about that is that we should always consider that soil infiltration rate is not a static absolute. And even a soil that is high in clay and slow at infiltrating water when it's just bare soil, even soils like that can, with planting and mulching and increase in carbon content and increase in living soil component of those soils, can change the texture of the soil and can increase the capacity of that soil to receive water over time. For example, oftentimes when infiltration basins are newly constructed in heavy clay soils, they will retain water for a long time. Once they are mulched and planted and have some seasons of establishment, that infiltration rate dramatically increases in those basins. We've seen that happen with over time, that the more planting and mulching that happens, the better the soil begins to respond over time, and the more capacity it has to infiltrate and absorb water. So just because the soil is clay does not mean it's impossible to infiltrate water, or that it's not worth trying to increase the amount of water infiltrated in those zones.
I believe Josh has, Josh, can you talk about the figures for that?
Yeah, and some of like the regenerative agricultural spaces, they talk about increasing soil carbon. And if the number that they kind of give out there is for every 1% increase in soil carbon content over 1 acre of land, you can increase the water storage capacity in that same soil by 20,000 gallons. So, a 1-inch rain over 1 acre is 27,000 gallons. So that's a pretty big amount of storage that we can increase by increasing the soil carbon, which is again adding plants and compost and mulch and things like that, and really building the soil layer. So they've seen increases of anywhere from 6% to 9% on some situations. So that's a lot of water that we could be storing in the that healthy soil layer as we increase it.
It tends to build on itself too. Once you start that process of mulching and growing plants, then it sort of tends to build on itself. The more moisture that can get in, the better the plants do. The deeper the roots grow, the more carbon gets incorporated into that soil. The more atmospheric carbon is sequestered in the soil, and the soil then becomes more have a greater capacity to absorb that moisture going forward. So it's a regenerative process. So I don't think we should think of infiltration capacity necessarily as being a static or fixed thing when it comes to these curb cut basins. I think we should see it as something that will improve over time. Other considerations obviously are the slope of the property, the grade of the street, the speed with which water is moving as it flows down the gutter is something to take into consideration. That's true of the surrounding properties. The elevations, the relative change in elevation between the sidewalk and the street itself, the elevation, natural elevation of the parkway is something to be considered. Also, it matters the groundwater level below the site. If the groundwater is super high, then that site may not be able to take in that much water. If the groundwater is quite low, then obviously there's more capacity to infiltrate continuously new water into the zone. So groundwater levels, existing groundwater levels matter. Our hope is to top those off and raise those groundwater levels when we can. The other thing would be the presence of existing street trees. You can see, if you recall some of the images from Brad Lancaster's work, the trees are right in the infiltration basins, and a lot of the photographs we saw show the trees planted right in the basins. And with new trees, they can be established in the basins in slightly elevated zones of the basins. But when you're dealing with existing street trees, you want to be careful about bringing a whole lot of water into the direct root zone of that tree. So it might be better to bring it adjacent to the tree where the tree can reach out and access that water. So it's of concern. You don't want to flood an existing tree's root zone with water that it had not.
Yeah, you also don't want to cut roots in order to bring water in. So you want to do it as close out to the canopy as you can or further out.
Yeah. We don't want to injure existing street trees, but we do want to bring water into their groundwater regions where they can directly benefit from it. Other concerns have to do with historic or archaeological preservation in historic sites near the Mission, downtown near the Presidio. Places like that, there might be archaeological or historic considerations. Those are things that might come into play. Location of utilities is a big issue. Underground utilities, if there's electric utilities and underground vaults, probably not a great spot to be infiltrating a whole lot of groundwater in those zones. So that would be something to consider in selecting a site for a curb cut basin. And then of course the adjacent land uses would be something to look at as well. You can, I'm sure, think of an example of something where it might be not advantageous to increase the groundwater depending on a use of an adjacent site. So those are things to consider when choosing a location for curb cuts. But we feel like there are many, many sites, many locations throughout the city of Santa Barbara and other South Coast communities where it would be very simple to do curb cuts, and they're such a low cost method, and potentially has a great return on investment to create curb cuts. So the current design standards, I don't know, Barbara, did you want to talk about this?
Yeah, I can talk about that. I reached out to different government entities about current design standards so that we would have the most current information for the webinar. In Carpinteria, they don't have standards for public works construction, but curb cut designs, if people want to do them, are evaluated, and it would be a custom design case by case. The city itself has not done any curb cuts in the public right of way, but they have done some in parking lots. So anyway, this is a place where community input could be helpful in creating both the desire and the actual implementation of more curb cuts in the public right of way. In the city of Santa Barbara, there is currently a draft of city standard details for curb cuts and bioretention planters on city streets. And I believe it's going to be in a couple months. They want to make those, they want to finalize those. So they're welcoming citizen input on those. And there are city departments that are actively installing curb cuts in select locations. The Creeks Division has been doing curb cuts for probably 4 or 5 years in different locations. I know that there's one on Carpinteria Street, and there's some on Quarantina Street. And they are actually actively asking people to notice where there might be good opportunities to do curb cuts, for them to do that and let them know. So there has definitely been a shift in the regulations about curb cuts in the city of Santa Barbara in the last 5 years or so. In the county of Santa Barbara, they are right now, they don't have the current capacity to make a shift and redo the standard engineering designs for either new projects or retrofits in the public right of way, but they are working on updating the engineering design standards. So citizen input could be given during this time. It seems like a good time to do it. Goleta, unfortunately, we were not able to get in touch with anybody and find out about their current design standards. So we were not able to give the most current information about Goleta right now. That's about it.
Okay. So I think now would be a good time to go to questions.
Yeah,
Can
so
you
I have,
access those?
yeah, I have, it looks like 11 questions here. And let's see, somebody has asked about how to store rainwater collection, which is a general question, not specific to this webinar. And I suggested that you can reach out to us at info@sweetwatercollaborative.org, and we can communicate with you about that, or also look on our website. We have a lot of references about that. The second half of the question is, do you need city permits for curb cutting? And yes. And what more do we want to say about that? I'm not sure where you are, the person who asked this. Sounds like you're in a city. I mean, in a city. So you would go to Public Works And let's see right here. If we're getting, okay, you're in unincorporated Santa Barbara County. Thank you. So my understanding is that you cannot do curb cuts currently in unincorporated Santa Barbara County, but you can reach out to the county to try to get those regulations changed. Here's another question about, we saw the saw cutting the curb. How did they cut the horizontal part at street level? So I've seen you do that, Fred. So a grinder, right?
Well, you can angle the concrete saw to make that horizontal cut at the curb surface with a slight angle downward into the basin. And then typically that chunk of curb is broken out with a sledgehammer, and then the detailing is done with a grinder to smooth and grind the edges so that it becomes smooth and that the fall into the basin is exactly what you were hoping for. It can be a challenge because the saw is not necessarily designed to cut in at that angle, but it is possible to maneuver the saw in such a way that you can get the cutoff blade into the concrete at the right angle to remove the curb.
And I think that on the Sweetwater website, under past projects, we have pictures of the project at the Wake Center in the parking lot doing curb cuts, and we have some pictures of Fred working with the saw, and you might be able to get some visuals of that by looking on our website. I have a question about if you can use an air spade to evacuate around tree roots to install infiltration basins.
In some situations, sure. Yeah. I mean, it could be helpful, I imagine, in some situations where you have a big tree or something that you want to protect. But ideally, like you said earlier, you'd be doing it out into the drip line, so you hopefully you wouldn't be near anything super big. And any little feeder roots, those will regrow pretty quick. But just want to get any big main roots.
Any tree root that gets to be much larger than about, a normal human forearm is something that you want to avoid damaging or messing around with too much. So we would typically prefer to stay further toward the drip line of a tree and avoid those major arterial roots of the tree. But certainly there's all kind of ways to open that soil up in the zone where you're trying to get infiltration. And it just kind of would have to be a case-by-case look at the tree roots to determine whether it was something that could be severed or worked around without consequence to the health of the tree.
And next question is, does Santa Barbara have enough rainfall throughout the year for curb cuts to take over some irrigation systems? So I would just like to say that we are talking about just putting water into the parkway here. We're not talking about bringing water further into residents. And so in the parkway, I think that the key is really climate appropriate plants. Street trees are chosen. They typically do not get any irrigation except rainwater. And even in Tucson, I've worked on installing some curb cuts in Tucson, and they choose climate appropriate plants. So I don't know if anybody else wants to address that.
Well, if you're irrigating the parkway, that potentially could eliminate your irrigation if you're doing some irrigation out there. And it might help affect a tree on your property if it's like close enough within range of the basin to help eliminate some irrigation need in that way. But yeah, like you're saying, it'd probably be hard to eliminate the entire need.
Yeah, well, there are other ways. There are other sources of rainwater that could be used to eliminate irrigation systems on property, but that's not what we're talking about right here. I just want to move forward because we have about a dozen.
There's no
left.
doubt, there's no doubt that any rainwater infiltrated through a curb cut basin would reduce the water requirements of any plants in that general area by banking that water in the soil. So it may not completely eliminate, depending on the types of plants present or types of plants envisioned, but if the right types of plants are planted, it could certainly almost completely eliminate the need for irrigation, would certainly reduce water requirements without a doubt.
Yeah, like you were saying right there, I was immediately thinking of a hedge planted closely to a curb. You know, that would be a nice situation where, you know, Eugenia, you know, doesn't need a whole lot of water, but, you know, maybe trying to establish it, that would be a good source of water for something like that, a hedge.
Sure.
So we have about 20 questions now. I'm not sure if we'll get to them all, but we're just moving along. Someone had a question about soil types, but we did answer that in the presentation. We have something about if we had to choose between curb cut and curb core, which one would it be and why? Can a curb core get clogged with mud or other things?
Yeah, that is that's the issue with a curb core, is that it's much more prone to clogging. And a curb cut is wider and much less likely to be blocked by debris. Curb cores need to be cleaned out regularly. They're much more discreet, but they're more prone to clogging. So it would depend on whether someone was dedicated to maintaining that curb core, or whether or not it's going to be sort of left to left to itself to be maintained. If there's some maintenance available, if someone's willing to clear the core, then it might be a better choice, just given the pedestrian traffic or whatever considerations. But I think case by case determination, they're both strategies, and one may be more appropriate than the other in given circumstances, but definitely the core is more prone to clogging than the curb cut.
And the curb cut can also infiltrate more water at once because you can make it wider and more water can come in, whereas the core is smaller diameter. So what changes in standard road details are necessary to protect the road surfaces? I don't know what they would be protected from because stormwater would be coming down there anyway.
Well, perhaps the question speaks to stability of soils with infiltration, and obviously that's of concern. Soil stability in the roadway would be something to be mindful of, but we don't see that that's typically an issue with city streets or engineered well enough as they're built to withstand the additional infiltration in the parkway zones. So I'm not sure if that's what the question is speaking to, but that would obviously be of concern for city engineers and people designing curb cuts and attendant roadways would want to be mindful of stability issues. I'm not sure that's what the question was speaking to, but obviously there is some concern there.
Yeah. How long does soil layers last? Is it necessary to replace or rebuild the soil profile?
I don't think it's necessary to replace or rebuild the soil profile. That doesn't mean that it wouldn't be helpful to take measures to improve the characteristics of the soil. But I don't think it's really indicated to necessarily replace the soil profile. Clearly, there's all kinds of strategies with curb cuts. We've seen the city of Santa Barbara do some very high capacity curb cut maneuvers where they create a large, deep vault, and they're backfilling that vault with crushed aggregate material that still allows for a large volume of infiltration of water. And some of these are quite large and can take in a large capacity of water. And they're simply removing the soil profile and creating a giant void that can receive a large volume of water, and then allowing that water to migrate into the surrounding soil area. So they are, essentially removing the soil to do that. So it is possible to remove soils and put in, better character soil, but I think our philosophy is one of the least intervention is probably the best, and simply creating the basin and then working to improve the character of the soil that's there is what we typically recommend and typically try to do.
Okay, I have a correction to something that I said. I see that Santa Barbara County provides encroachment permits if the request is reasonable and typically does not increase maintenance efforts by road crews. So my understanding from that answer is that it is possible to do curb cuts in unincorporated Santa Barbara. So I apologize for any lack of clarity about that. I have one, are steeper slopes less appropriate for curb cuts, and why or why not? And certainly the speed of the water. Anyway, does anybody else want to address that?
Well, I guess there's the steepness of the slope of the street and the velocity that water's traveling down the street. Although typically with with these eddy basins, as Josh described, the water is very placid in the basin to the side. So the velocity of water in the gutter doesn't necessarily translate to erosive force within the eddy basin. So that there is a concern about slope with regard to the velocity of the water in the gutter. But I think also maybe this question speaks to the slope of the surrounding property. And just as a rule of thumb, the more steeply sloped land is, the less water you want to be infiltrating into that soil profile. So typically we try to stay in less than a 15% grade for any infiltration, and preferably less than an 8% slope to have a good infiltration, safe infiltration, because soil stability is a concern. When you're putting water into soil, you are giving it more fluidity, and there are geotechnical concerns with slope and infiltration of water. So we want to err to the side of being conservative about the slope of any property that we're putting water into, just with that thought in mind. So yeah.
So a couple more clarifications. The city of Santa Barbara does require permitting for curb cuts in the public right of way, and you would do that through Public Works. I would say the Public Works is who you would reach out to in any municipality if you are interested in pursuing this. And then I also got a comment that splash pans or riprap on the backside of the inlet would aid in most conditions for undermining road surfaces. And that is back to the question about road surfaces. And I have a couple more at least that I want to get to. I'm sorry. Doesn't look like we're going to be able to get to all of them because we want to do a little call to action here at the end. Any danger of creating sinkholes under the street?
That's what we were talking about before, with stability of the paving. And I think that to the extent that the city street is engineered according to Public Works standards, it should be pretty good in the circumstances of a small curb cut and infiltration basin in the parkway zone. We can't know what the specifics are of the soils under, in every spot, but typically the street would be engineered in a way that would prevent that kind of thing from happening. I'm sure that the city and county, all the public works people would have concerns about those kinds of things, and those would need to be addressed. But
Yeah.
still, we feel like it's worth it's worth addressing those things as they come up, because of the potential benefits of the capture of that water.
So there's a question, any way to create a gate to avoid sustained ponding in the basin? And the first thing that I want to say is we didn't talk a lot about the concept of an eddy basin, but an eddy basin is one that will fill up, and then once the inlet and the outlet are the same, so that the water rushing down the street will fill up, and then once it's full, it will keep running down the street so it won't overflow. I'm not sure what you mean by ponding here. As the infiltration rate increases, as it becomes more biologically rich soil, then there shouldn't be ponding. It should just infiltrate. But in terms of creating a gate, it's possible, so that you're saying that some of the time you don't want to have the water coming into the basin. I'm not sure. Maybe somebody else wants to take this on also. Anything else anybody wants to say?
I mean, it could be possible to, for example, to throw a sandbag into a curb cut to prevent more water from coming in, or prevent water from coming in to the curb cut. But typically we allow them to fill to capacity, and then when the rain event has ended, that basin will retain water for as long as 48, 72 hours. We don't want to see things holding water beyond that 72-hour period. So a few days, we would expect the water to infiltrate. And if it doesn't, then there's an issue. I have experience with basins that were newly created, and the first time they filled with water, a week later there was still water standing, and I ended up having to bail out water from the basin in order to prevent mosquitoes from breeding in it. But that very same basin, after a couple of years of existence and with mulching and planting, now when water enters that basin, it rarely persists for longer than 24 hours. It's the soil has improved its character and its infiltration capacity over time, so much so that initial ponding in the bare raw clay when it was first excavated is not the current condition. So it does improve over time.
We just have time for a few more. Somebody is giving some suggestions about where to do curb cuts in Santa Barbara, and you can reach out to the Creeks Division and talk to them directly, because they have asked for people, if you notice that there are places that would be good to do curb cuts, to let them know. And somebody asked, with the curb core, what is the outflow for that? That would
There
Yeah.
is no outflow with the curb core. These are all eddy basins. They're basins where the inlet is the outlet, as Barbara was describing. So water flows in, and when the basin becomes full, there's simply no more room for water to flow in. So water just stops coming in, and the basin becomes a tranquil little side pocket to the main flow of the water in the gutter. And the curb core works in the same way as the curb cut in that regard, that once the basin is full, water simply stops entering through the curb core. So it's not a flow through situation. It's an eddy basin. So there is no flow through. There's no exit for the water other than infiltration. So really, it's the infiltration rate that limits the amount of water that can flow into the basin.
So we're going to have to limit the questions right now, because we're getting close to 1 o'clock. And I just want to say that this webinar was put together in part to create a call to action of citizen advocacy for this practice in our area. And We are open to having a follow-up meeting like 2 weeks from today on Zoom as a meeting, not a webinar, which means that everybody can talk to each other to figure out strategies, people who are interested in taking on this advocacy. And one of the ideas is that it is needed to do maintenance, a periodic maintenance on curb cuts, and people who don't necessarily have a home or don't have a place where curb cuts are easily able to be put in could adopt a curb cut. And again, some of the calls to action are, we'll send out invitation to that follow-up meeting and see if there is enough interest, even if there's just a few people to move forward with that. The idea of adopting a curb cut, if you're in the city of Santa Barbara or you're around the city, letting the Creeks Division know where you think there are good locations for curb cuts, advocating with your municipality or the county about making these design standards that are best practices and making this a more common and legal way of really benefiting our community. Anybody have anything to add? Fred or Josh?
I was just going to say that if anybody, that we are committed to collaborating with the public agencies responsible. We've had discussions with the Creeks Division at the City of Santa Barbara about this and are in ongoing discussions with them. And we're very eager to be able to help them locate areas where curb cuts would be appropriate. So I would, encourage people to communicate with us as well if they have ideas, and reaching out to the city seems more than they would care to do. We're actively engaged in that process ourselves, and we'd be happy to hear suggestions of locations and then help to evaluate those to bring to the attention of the city of Santa Barbara and other municipalities and the county as well.
Yeah,
I'd add that video and picture whenever possible of these, problem areas or ideal areas, however you want to frame them. They can be the video and picture can be very powerful to kind of see where that is. And even sometimes the after effects of things like erosion in some places where, I know erosion's kind of getting into a different detail than a curb cut now, but maybe places where you see a lot of erosion, there can be curb cuts above that can mitigate some of that erosion downstream. But yeah, just kind of those video and pictures of those ideal areas and problem spaces.
and just to reiterate what Fred said, we are very interested in working with the public agencies, and we appreciate all your work. And thank everyone. Thank you very much for participating in this webinar, and I look forward to having more of a dialogue with people in our meeting in 2 weeks. Thank you so much.
Yeah, thank you very much.